I can answer. I think it's also nice to have an interactive session. So yeah, feel free to interrupt me. Shall I share my presentation?
Great, thank you, Marzieh.
Yeah.
Sarah, you can stream the YouTube now if you want.
Yes, we're all set. Thank you.
Thank you.
All right. Okay, let's see. All right, so you should be able to see my slides, right? All right, nice. Yeah, like I said, my talk is gonna be about building the next generation of multilingual language models. And my hope is that you walk away from this talk learning a few things. So one is why it's important to work on multilingual problems and frameworks. Also get a sense of what it takes to build a state-of-the-art multilingual language model. And of course, there are still challenges and open questions. So we will also have some discussions about what is still left to do there. And hopefully you as future researchers can also, if you're interested, work on that. Yeah, let's start by just in general why it matters to work on multilingual problems. I think this room, to me, at least, looks like a really diverse room. I don't think I have to justify. I don't think English is the only language any of you speak. So there are more than 7,000 languages spoken in the world, and it's really like just a lot of people around the world. And when we think about this amazing technology that we have with the models, they barely cover a few of these languages. So essentially, this technology is not accessible to people around the world that are not familiar with maybe like the details of that, the English language, or like the few top languages that usually these models are good at. And this is not really great, but it's also have been the case for many years in NLP as well. Just the fact that different languages are treated differently by researchers. So there's not always a correlation between the number of speakers of a language and the amount of research work on that language, as well as just the data available for that language. So it really depends on a lot of factors, and this disproportionate attention to different languages have been existing for many years, continuing into the language modeling world. When we think about the data that is used in training these models, most of the data comes from the internet. And when we look at the composition of the internet, it makes sense of why there's disproportionate representation for different languages. So without really trying to do anything about it, there's always, it's always going to be mostly English, and then limited, it goes down essentially for different languages. But when we think about the composition of languages on the internet and how it reflects the world, it's not really a one-to-one. So for instance, most of the internet is English, but most people around the world don't speak English. So yeah, I think in general, it's important to work on multilingual problems to have fair, accessible technology across the world. So the main problem that we have, okay, so now we decide to work on multilingual problems, but then where to start and why it's actually hard to do that. And the main problem is this limitation on available data. So when we look at the available data on the internet, around 80% of languages have almost no text representation. And this is around like 1,400 languages have some form of text corpus that we can use to train models. But even like that, just like that 1,000 is just very the quality and the size varies across the board. So here, for instance, you see two statistics from like Wikipedia pages, which I think everyone is familiar with, and also Comment Crawl. So Comment Crawl is kind of like a snapshot of the internet, different pages at one point in time. And it's very clear that data size varies and it goes down as we go to mid-resource and low-resource languages. And it's also not always proportional in different corpora available. So we talked about quantity of data, but quality is also a big part of the equation. So we do need high quality data to train good language models, and especially for low resource languages, we see that the available data are usually in lower quality than more high resource languages. So this brings us to Aya. So Aya is an initiative that we at Cohere for AI have started 2 years ago, and our goal was to accelerate multilingual AI progress. And the point that we started with was data. So all of these disproportionate and lack of available data for many languages. So this was where we wanted to start. And our goal was, and it still is, to release state-of-the-art open source data sets and models across many languages, but also in this process change where, how, and by whom in general ML progress is happening. And what I mean by that, we built a community of people and we collaborated with them to develop this data set for many languages that we were interested in. So let's take a step back and think about the general recipe to train a language model. I mean, there are like some common steps across the board, but then also like there are details that might be different. But often, if not all language models, they have a pre-training stage where you use unlabeled corpus, just like text on the internet, to train a model. The objective here is to learn to predict the next word in the text. And because it's unlabeled text, so it just can be like you can imagine like a Wikipedia page. So you don't need it, just like the text itself as input. The data size here is huge. So usually billions, if not trillions, more recently, of tokens are often available at this stage to get to a pre-trained model. Once we have this pre-trained model, the next step is usually to do supervised instruction fine-tuning. And we call this supervised because we need some form of labeled data. And usually the format of the data in this step of training is these like pairs of questions and answers, or like prompts and responses. So the objective is not predicting the next word anymore. It's about getting a question and learning for each question to generate the answer. Having these pairs are expensive. Like these are not really easy to come by because you have to create these like questions and answer pairs kind of in some way manually. And then the size of available data at this stage of training is quite small for many languages. And this is where in our Aya initiative, our focus was. So address the lack of data, label data for instruction fine-tuning for as many languages as we could. Yeah, so we ended up, the recipe that we ended up doing was to use a pre-trained model trained on 1 trillion tokens, the MT5 open model, and then generate instruction data, pairs of prompts and responses, a couple of million examples there, and that was the Aya data set. So when we talk about prompts and example or prompts and responses. It comes from this really nice, maybe now considered old paper, the T5 paper, a few years ago, 2019 or 20, I think. This idea that we can train models on multiple tasks at the same time, and as well as multiple languages at the same time. And you see here, for instance, an example of like a prompt, like translate English to German, this sentence, like that is good, and then the answer, which is the translation. And then there are like different tasks, like there's like one about summarizing, one about like a question, general knowledge question. So it can be essentially our goal in the Aya project in the beginning was to create this data set in as many languages as we can, this type of prompt and responses. So the data artifacts that we ended up creating covered 114 languages, and this was a collaboration with more than 3,000 volunteers in our community. So really people passionate about including their language in this technology and getting this, getting their language represented. So one example, I think, maybe I can actually start here. So actually like the simplest form of data collection we did was a super simple UI and just having like a place for just prompt and completion. And also like picking a language that you are adding the example for. And we asked people to write examples. So the guideline we gave them was also like examples that are more related to something about your language and culture that might not be captured in English data sets. Like for instance, recipes of food or questions about geography of your country or literature of your culture, like these sorts of questions that are very specific to each language. So this is a very valuable data set that our volunteers contributed to. But then we also, because we wanted to scale the size of the data that we collected, so we also took existing data sets and reformatted them to make them into this prompt and completion style. So, and this is like templating an existing data set. So for instance, here you see a data set that is about textual entailment. And there's like a premise, like there's some context, some hypothesis, and then you say whether you can conclude that hypothesis from that premise, right? But the format of the data set is not, there are like multiple fields and it's not really in this question and answer style. So from this data set, we can template that in different ways. So for instance, one is just like plug in the premise and then say, based on this paragraph, can you conclude that, plug in the hypothesis? And then this template, you can imagine we apply to every example in that data set. So that's a really easy-ish way to scale the data that we are collecting. So you have to write the template manually, but then you can apply that to every example in that data set. And this is an English example, but we have done that in also other languages as well. So what we ended up collecting in this project was, and we released that in two separate forms. One was the Aya dataset, which was the purely human annotated examples. And this is super valuable. We ended up with covering 65 languages. I see a question, but I think maybe this is actually a good question for the end of the, thanks. And the second part was the Aya collection, which was this like templated and translated data. So to scale the size of the collection. And both Aya dataset and Aya collection, they ended up being and still are the largest multilingual instruction following datasets available out there. with completely open source and can be used in training multilingual models. But now what we can do with these data? So our original goal have been to build multilingual models. So we have been doing that in the past year. We actually have 3 generations of multilingual model. And I want to tell you about how we build each of them and how we improve the previous generation and develop the next one. So the first model that we worked on is the AYA 101 model. For this model, we use the pre-trained model, like I said, the MT5 model from Google. This model, MT5 covers 101 languages. So you are bound by the languages that your pre-trained model covers, essentially. So that's also why this, even though we collected data in 115 languages, we ended up training a model for 101. And then we used the AYA collection that we got, SFT fine-tuning, and we have the first generation of model. We did play around with different sampling ratios of different data sets. For instance, the AYA data set, like I said, because it was manually curated, really high quality and diverse, we oversampled from that. And then from like the AYA collection, which was generated with templates and translations, we still sampled from that, but on a smaller size for the model. And then for evaluation of a language model, I do want to discuss evaluation a bit more in the end. But here, let's just say we looked at different types of tasks. So we have like discriminative tasks where the answer is usually like like multi-choice question answering or yes/no answer. We also have generative tasks where the answer is just like full-on text. We also did human evaluation and safety and toxicity evaluation. So one thing that I think is actually quite interesting is that different types of data that we added in the collection had different impacts on different evaluations, which I think is quite nice. So, and that's also like a good lesson in general, that one number of one evaluation only captures one aspect of what you are doing. And usually like having like a fuller picture of how a model is working is by running multiple different evaluations. So for instance, here on the left side, you see that on discriminative tasks where we just have to essentially predict the option of like a multi-choice question answering type of evaluation, we see that when we add templated data to the training, we see a huge improvement from the base model. But with translated data, and even more importantly, with human annotated data, which is really high quality, we don't really see a difference there. But on the other side, when we look at the right plot, when we look at win rates in an open-ended generation task, we see that each of these have an impact. Each of these types of data sets have an impact. And like the human annotation one actually has gain on top of everything else. So it's like a really nice way that each type of data is contributing to different downstream tasks when we are developing these models. So I talked about AYA 101. I do want to talk about the next generation of the model, which was AYA 23. So we started with going broad, trying to cover as many languages as we want with AYA 101. And then with the 23 version, we focused on only 23 languages, and we tried to improve the quality of that even more. We did that by changing the base pre-training model. So for that one, we used the Cohere Command R model at that time. Again, we used the same AYA collection samples from before. We also add on top of that some synthetic data that we generated. And this was a really nice improvement over the previous model. So with IA 23, and we did release this model in two sizes, 8B and 35B. And when compared to other multilingual models of similar size, they were as good or even better on different evaluation sets. And this is also true for open-ended generation. So win rates, when we have like two models, like for instance, IA 23 and GEMA 101 at that time, they both generate answers for the same question, and then we use a language model to say which one is a better answer. So with IA 23, we already had really nice gains over the existing models. But then a few months later, of course, progress is happening. No one is standing still. And with new also techniques and innovations, we wanted to release, to work on like even a better model. So that's where the project on IA Expanse started. And IA Expanse, the goal was to build this really a state-of-the-art multilingual model, trying to be as strong as we can get on all these 23 languages. And we succeeded. So at that time, with all of the state-of-the-art, at that time it was GEMA 2, GEMA 3 was actually released yesterday here today in Paris, which we have to now also compare against. But yeah, up until yesterday, IA Expanse was the state-of-the-art model across different tasks. And the training recipe that we used for IA Expanse included a few innovations. So one was to use, we used a technique that we published on previously called multilingual arbitrage. So what we do in this scenario is that we generate synthetic data using multiple teacher models and a reward model to score the generations, and then pick that one to use to train a model. So here, essentially, the pool of teachers that you have should hopefully cover all of the languages you are interested in. And then you sample from different teachers to per example and per language. Then based on the reward model, it might come from different teacher. And this way, the hope is that the quality of the synthetic data is quite nice. Yeah, so here is actually like a better example of that. So for this, for IA Expanse, the pool of models we used, we had IA 23, GEMA, Quen, Llama, Sea Lion, like a few existing multilingual models, and then a list of prompts in different languages. And then each completion came from a particular model based on the score that we had. So the second innovation that we did in this, in training IA Expanse, was preference training in a way that, and I didn't really talk about preference training earlier, but it's usually the last or one of the final steps of training a language model, where the type of data that you have is in pairs of, with some annotation of what is better, what is worse. And the hope is to steer the completions of the model towards the better generations and away from the worse generations. So yeah, this was another technique that we used. And then lastly, we also really explored model merging for this project. So when you train different models at different stages, you have all of these checkpoints that you don't really end up using most of them. And model merging is a nice technique where you can essentially merge different checkpoints. And like in the simplest way, you can just do linear merging, just weighted averaging of different layers. But there's also like different merging techniques like slurp ties, dare ties. And yeah, so we explored different merging scenarios to also see like what works best in the end. And we ended up using all three techniques to develop IA Expanse. So going from the IA 23, which was released in May, and IA Expanse was October. So just doing arbitrage, which improves the quality of synthetic data, we go from 39% to 48%. Adding model merging on top of that, we go up to 53%. And then with the preference training in this way of iterative DPO and combining that with also merging, we have the gains of up to 60% when we compare with IA 23, so the previous generation of the model. And this also scales well. So the previous results were on the 8 billion parameter model. And we also released a 32 billion, which we see a similar pattern, a strong model that outperforms the competition on different, and this is like really like a hard task, the ARENA hard task. Right, so I do want to talk about evaluation a little bit because it's a big part of how we develop models. So you do need evaluation sets to quantify and measure progress. And evaluation should be meaningful. So it should be, of course, it should be fair. So there shouldn't really be like train test contamination, but also it should be capturing different aspects that we are interested in training a language model. So for instance, it can be like a very general knowledge trivia type of questions, or it can be like a very specific, like in domain, like maybe like medical questions. It really depends on what we are trying to capture. And when we talk about multilingual problems, it's even harder to build these evaluation sets. So first of all, there are not that many multilingual evals. And also, even the ones that are out there, the coverage of languages are not that great. So existing data sets cover between something like 2 to like 8 languages. So this is very important when we develop the multilingual models to also simultaneously build evaluation sets that can measure progress here. So one thing we studied was there's this kind of, it became like a status quo data set to evaluate called MMLU, which is the exam questions for in English on different topics. So here you see the topics on the x-axis, like from, I think it's a combination of like high school and college exams. So there's like, I don't know, like biology, clinical knowledge, astronomy, like different topics. And we did a study where we looked at whether it makes sense essentially to translate this data set or not. So if we translate this data set to different languages, whether the annotators agreed on the answer, on the correct answer, or disagreed. And we see here, like the green bars are the agreements between annotators, and the red bars are disagreements. And we see a really nice pattern, in my opinion, that is also like a very clear message. So we see on the left side with high agreements, we have these sort of exams about like algebra, physics, computer security, like STEM questions, general, like math, STEM, really like very specific science. And then on the right side, what the topics of the exams are history, moral scenarios, professional law, philosophy, all of these topics that maybe when we translate the disagreement between the answers, because it comes from also like different cultures, maybe the answer, or different points of view, really. So this was a nice signal that, oh, maybe we shouldn't just translate existing English data sets to get multilingual data set, but we should do that differently. And oh, yeah, so we have like STEM topics on this side and social topics on the other side. So what we ended up doing was last December, releasing 2 different evaluation sets. So one we call Global MMLU, and we only translate the culture agnostic topics in MMLU. And we also do post-edits, manual checks and post-edits of the translations. And we generate that for 40 languages. So this was essentially, if you want to evaluate the model's STEM knowledge or general knowledge in different languages, you can use that data set. The second data set we built, we call it Include. And this one was focusing on really like the specific, essentially like local exams. So this was a community effort to find exams in different languages and countries, and then process them from PDF to text to include in an evaluation set. So when you evaluate a model on Include, the score you get is how much knowledge a model has about the culture of that language. So the driving license exam, the literature questions, like these sorts of questions that don't really come from translation necessarily. So our hope is together, both of them can help provide a picture of how language models look like and help develop the models that are multilingual and also capture both general and local knowledge about a language. Right, so in the last part of the talk, I want to go through a few ideas and current open questions that still exist. And I think it would be cool to also, I definitely like to then hear your thoughts and of course questions, but also just your thoughts about where to go next on building multilingual models. So one question, or like still like an open challenge, is still checking the factuality and truthfulness of generations. So when we so we can evaluate a model on existing eval sets, but of course they don't include all type of questions in the world. So you still like to have like some way of getting a signal that to a random question that you ask the model, whether it's actually generating truthfully or not. So that is something that still, even for English, it's not fully solved. And for multilingual, it's a big gap there, and we cannot do that at this point. The other open challenge, I think, is still evaluation. It's definitely not solved. We talked about it a little bit, but I do want to highlight here that it's, at the end of the day, each evaluation set has just like looks at one aspect of a model performance. So for instance, here you see the same set of models evaluated on 2 different benchmarks, truthful QA and MMLU. And the same model that scores the highest on truthful QA is actually the lowest on MMLU. So the question of aggregation of results, like how, so what is the takeaway essentially here? Like what do you aggregate if you want to increase, essentially, if you want to be comprehensive in evaluating your model, you increase the number of benchmarks you use, but then how do you conclude from that result? Is it just like weighted averaging of everything, or is there some meaningful way, depending on the downstream task that you want to, like where the model is going to be deployed and used, and what is more important and what is less important? So this right now is a very manual checking by everyone, but yeah, there's still, I think, a lot that we can explore there as well. Another aspect that we didn't talk about a lot today, but I think is important, is safety of generations of the models, especially when we talk about multilinguality. This is very much underrepresented right now. So there can be like privacy issues, misinformation, discriminating and toxic content. And then when we think about deploying models in applications, so especially models working with everyday human beings, it's very important to think about this aspect. So for instance, if a child is going to have access to a model, like how do we expect the generations to, like, yeah, what are the safety measures we want to have? And yeah, in a multilingual setting, this is even more unexplored. And then lastly, the question of data is still, so I started with data and I want to wrap up with data. And it is still an existing and big question in my mind. So, and there are different aspects to it. So one is like, whose data are we using to train these models, about like data ownership and licensing and whether it's fair or not. That's a whole area. But then also the question of really like, how much data do we need for going from like zero in a language to get decent? And that's not an easy question to answer, like how much and what type of data. So these are important questions to quantify, because it is connected to human labor behind it, and using human annotations responsibly is also important when we talk about developing language models. And yeah, that's it. So I don't want to wrap up by saying that language models are remarkable. They are really, just looking back at the last 5 years, how far we have come. I don't think many people could really predict that. But it's also not solving every problem, and there's still a long way to go. And if we are building this technology for the world and we want everyone to use this technology, we should think about who are the users, and that's why the multilingual aspect of this is important. And we also need to involve people that speak these different languages in building these models, because that's the point of view that is missing in general. And I do want to also mention that working on multilingual framework in general, it's not really doing it out of the, like, just because we want to be nice and get this technology to everyone in the world. I think it's a very challenging problem. And when we try to solve challenging problems, we also come up with brilliant ideas that end up progressing the field in general across the board. So when you look at, for instance, the history of where we are with language models, so the architecture, transformer, before that attention, RNN, attention in RNN, all of those papers were first to solve machine translation problems. When we think about how the tokenization is done today, the paper on that came in 2018 in machine translation. So really trying to solve problems in a multilingual setting resulted in where we are with this technology right now. So there is value there when we try to solve hard problems, because we end up developing really smart ideas. So I think for that, even if you don't care about getting this to the world, I think it's valuable to work on multilingual problems. I do want to give a shout out to all of my collaborators. This was definitely not done alone. So in the AYA initiative, we published every work and every data set and model online. And these are the papers and my collaborators, both from Cohere and also our community of contributors in these projects. And then the 2 evaluation sets that we released were also huge collaborations. So the Include was collaboration with EPFL, and the Global MMLU was a collaboration with a big group of people. And all of these papers are also available online if you want to check them out for more details. Thank you. that's it for me. And I look forward to your questions. And I already see in the chat, sorry that I didn't get to the questions in the chat, but maybe we can go through them together now.
Thank you, Marzieh. It was great. I loved it. I finally managed to learn about Aya, the competitor of OpenAI. That was great. Before the questions are posted by me, but before I wanted to ask my students if you have any question from Marzieh. Any questions?
Yeah, and it can be about the talk, but also like general questions. So my focus was about Aya, but also, yeah, if you have any other questions, I'd be happy to help.
Don't worry, it doesn't need to be very complex question. You guys are learning NLP right now. So we know that you are not at senior level yet. So it would be great if you had any questions from Marzieh. Okay.
Okay, maybe while you are
So,
thinking, okay, go ahead.
yeah, so I'm the tutor for this course. So actually, I am also working on something like kind of multilingual LLMs. So my question is related to your this thing, whether you are targeting one particular downstream task, or are the models generalized? I mean, are they general purpose or task specific models also that you're working on?
Yeah, that's a good question. So to be honest, actually, so far, like with the Aya Expanse, our focus was first to build really a model that is good at general purpose. So as a user, you chat, you ask questions, and we wanted to cover essentially as many types of questions as we can in this form of general interaction with the language model. But now we are also thinking about, because we know there are areas that the model is not great at. So one area, for instance, is code generation. So it is not really like one of the main use cases of a multilingual problem, but I think it would be nice, like, I don't know, like I speak Persian, like if I give like the model a code in Python, the explanation, if it's in Persian, like that would be maybe like a nice touch there. So like these sorts of specific tasks, we haven't focused so far. So we just like build a general purpose model that you can chat with. But yeah, we are working on improving individual skills of this model.
Okay, great. Another follow-up question that I would have is, I mean, I might have missed in the presentation, but I will look into the paper as well. So, what are the languages that you are working on when it comes to the multilingual? Are you like, have you named them somewhere, the name of the languages?
Yeah, that's also a good question. I don't know what screen are you seeing?
Uh,
I think
I
it
can
was in
see
the
the hugging
beginning of
face.
your slide.
Hugging Face. Okay.
Yes.
So I actually didn't talk. So 2 weeks ago, we released also a vision, a multimodal version, but I really didn't get into that. But if you go to, for instance, like Hugging Face, like these are the list of 23 languages that we cover. And these are 23 that we also evaluate on. So we do have more languages in the pre-trained data. So for instance, like Thai is not one of these languages, but we know the model generates decently in Thai. Like there are some languages that are not, that we didn't target in post-training, but because there's some data existing in the mix, it's doing okay-ish on. And our next goal to actually expand this list of languages, so going beyond the 23 that we have here. And I did wanted to also share this, like the Hugging Face space. I mean, now the default is Aya Vision, but like this is also, there's the chat part. So you can try out the model here. And like there are also like examples here, like let's try a Dutch examples. So like these sorts of questions are the ones that we optimize the model for. So like this general knowledge or just chat conversation questions from the model. So it still generates, for instance, like in code, like it do decently, but yeah, it's not optimized for that.
Okay. Great. By the way, it's a very good idea to work with low resource languages, because people who use low resource languages primarily for their daily tasks, it's kind of not good to see that they're not able to get similar performance of these large language models on English languages.
Yeah, I definitely agree. And it's also like a surprising thing I learned in this process when we were collecting the data last year, was that there were like some people that are, so it was really sometimes easier to collect data in some languages, like for Tamil or Telugu, like we collected a lot of data.
Mhm.
But then for like Spanish, we really had a hard time to collect data. I feel like people who speak low resource languages, they really experience the problem that these models are not good at, and they're passionate about getting their language represented. So there's also this social psychology aspect of it, that collecting
Absolutely.
data, it's different across different cultures and countries. But yeah, I think it's a valuable, and yeah, hopefully we can bring this technology to more people around the world.
Okay, great.
I see some questions in the chat, Marzieh, from Silvia and Vicio.
Okay, nice. So I'm gonna just read the question, or if you want, you can also yourself read.
Go ahead.
So this language model is very inclusive. I'm already downloading it. But what do you think about language models that might respond with biased information or deliberately omit information? Yeah, I think that's a good question. So, I mean, every language model has its own bias that often comes from data, but usually you try to balance it at the data preparation step. So in the case of DeepSeek, for instance, like that is a very deliberate, like that's not a property of the data really. So the way that maybe this model refuses to answer some political or like controversial questions, that was something that they really incorporated in that model. So it was not really a side effect of what that model did during learning. But then some models, just as a like a side effect unintentionally, they have like some bias in their generation. There are works, research trying to address it. So there's like the question of whether you do want to remove this bias or not, which some companies I think do, some companies don't. And then there's a question of how to do that. This usually the best place to do this is at preference training stage. So essentially you can think about a language model learning all sorts of personalities and information from the internet at pre-training and then later on at SFT. And then during preference training, you are essentially steering the model towards maybe like the more unbiased personality versus the, I don't know, like the Reddit tech bro, like this type of, like that might be some bias, or like, because all of this kind of exists in a model that learns from the internet. But yeah, at preference training, and you don't need a lot of data. That's the nice thing about that. So you can do that with small amount of data that is curated for this objective, and then do some DPO, PPO, like there are different techniques to do preference training and hopefully reduce the bias of the model. Yeah, the next question is, what skills would you recommend for someone with a strong linguistic and culture-driven background who wants to contribute to multilingual language models? Yeah, that's a great question. So skills. I think in general, I would suggest to get really familiar with the failure cases of the models. So usually with every model release and every announcement is just talking about all of the great things that they can do. I also am partially, like today, I just talked about how Aya is great in this and in that. And they are really good in these cases, but then really trying it out and trying to see where they fail and why they fail. Like if your interest is about this, like the multilingual language models, and you have this really interest in the cultural aspect of it, try that in the languages that you know, really like especially cultural questions, and then see where they fail. That already is a big step. So really identifying the gap and what is missing. And I think really a good aspect that you can do is also building evaluations for that. Because to get a model good at that, you do need the maybe like a bit more like computer science background, or just like familiarity with training models and how things work. But if you, and that is also good, like that's also another skill that you can learn. But if you don't want to go down that road, I think identifying problems and building evaluations for that, that's a really valuable thing that you can have your own point of view added there. Nice. So there's a next question. I'm curious about Sapir-Whorf. The user theory or the language we speak shape the way we think, carry over. I was not familiar with that term. Is that what it called? That's actually a nice. So the question is if the languages we speak shape the way we think, and it also carries over to multilingual models. And the short answer is yes. I'm actually, in general, very interested in that aspect. Like a simple example about this is association of words and emotions or concepts with colors. Different languages associate colors with different topics or like concepts. Like we know, for instance, like red for Chinese is just like very about, I think, if I'm not mistaken, about prosperity and just like success. But then maybe like on the Western side, it's more like a warning, like it's always used in places like to stop or warn or like things like that. And like these associations also exist in your multilingual data. So, and color is a simple example to imagine this, like the differences between different languages, but there are also different aspects of that. And models they do also contain that. What we call usually a generation of a model that looks okay, but it looks weird. There's a term that we use. We say it looks translationese. So it's like, it looks good, like semantically it looks good, but you feel weird. Like there's something about it that you think a native person wouldn't really say it like that, wouldn't use that word. And this comes from just like one concept existing maybe in English, carrying over to the language you are testing. And yeah, that's another thing, that as we want to get these models more fluent in all of these languages, we should also think about addressing this problem. And there's a second question: have you worked on any niche first people languages, and are they more difficult? That's another good question. So I have a friend, we collaborated once. He's in Canada, so the language, I think, I don't exactly know don't quote me on the name of the language, but one of the indigenous people in Canada, he's part of that tribe and have been trying to preserve the text of that language that exists in museums and libraries in Canada. It's actually not for public, so I think some laws passed that they have ownership of the data in that language. And their idea is to essentially build first really like collect this data and preserve that, but also build technology on top of that. I haven't personally worked on that project, but we collaborated on another project, and we talked about these challenges in just like this sort of essentially like some resources that exist in a museum, not even displayed, and they have to go find all of those and try to get those and capture that. Thanks. And yeah, they are working on that, but yeah, it's really hard to say. And the set of challenges there is a whole other world. I think that's really important to work on. But yeah, we don't see that very often, unfortunately. And the last question is, how does this relate to translating animal communication? That's a fun question. I actually have a friend recently moving to a company. What is it called? Maybe I can share later. So there is actually a company working on animal communication, building a language model that understands animal communication, which I didn't know before. I haven't worked on that at all, but people are doing that. So I think they were collecting data from whales maybe, or like some dolphins, like some sea animals, and then trying to decipher the communications. I haven't worked on that, but I think that's really cool use case of language models. Ah, nice. And then there's a link to this term that I wasn't familiar with. Thanks for sharing. Nice. Another question we have, and feel free to jump in. I'm just going through, but yeah, you can also always ask questions. Since most people are trained in English, are there any poor outcomes if we prompt them in a language other than English? That's a good question. I think I had a slide that I moved it to, I thought it was maybe too long. Yeah, this was the one. Short answer, yeah, you can have that. So there have been this study on adversarial attacks on a language model. So getting a model to generate harmful generations. And what they saw was that if they, if I do this, yeah, if the language of the prompt is one of the more high resource or mid resource languages, very few of them are successful. So like 10% of high resource attacks and 21% of low resource attacks. But when they translate the prompts to, mid resource, when they translate the prompts to more low resource languages like Zulu, Gaelic, like a few languages that are really low resource, 79% of the attacks were successful. So there is definitely, and that's another aspect of working on safety of language models in a multilingual setting. And the reason is that we get different, we might think that a model is safe in one language, but it's very much open to attacks in another language. And your question about poor outcomes in general, so this was an example of really like adversarial attacks. So yeah, I think this can be a poor outcome, but if you meant something else about that, let me know. But yeah, models do behave differently when we use different languages to prompt the same question to them. But yeah, ideally, we want a model to behave the same. So if you ask a model, what is the capital of France, like a simple question, it should be able to, it shouldn't matter what language you use to ask this question. It should always be able to answer. That's the ideal scenario where multilingual models are really good across the board.
Thanks, Marzieh. You talked a bit about the challenges during your presentation, but what was the biggest challenge in training a multilingual LLM that is not English only?
The biggest. Yeah, I think data is definitely one part of that. So we have collected a lot of data, and now there's a question of quality of the data and increasing the quality of the data. So having good quality and also diverse topics. So like we want to have essentially a good representation of different use cases later on for the model during training. So building this data is not really easy or straightforward, and there are ways around it, but none of them are perfect, and there's still like a lot of open questions there. I think that's a big aspect of it. And another one,
What about the computation? I was just curious, is that a problem, or you don't have?
I mean, we do. So we are fortunate that we can do that, but of course not everyone can. But yeah, you do need a lot of compute, and there's always, the more you have, the better you can get. In general, because we want to, so we are the research lab that we release everything openly because we want people to use these models. And when we think about like developers and people using the models, they don't really have access to a lot of compute. So working on smaller size models are more valuable, I think, for the community because they can fit that on 1-2 GPUs. And then the question of really trying to squeeze all of the knowledge into a small model, that's a more challenging questions rather than just going bigger and using more. Yeah.
Nice. And what was just in case of curiosity again, what was the language that you guys struggled the most significantly to train?
I mean, it's a good question. So in the list of 23 languages that we have, none of them are really low resource. Like there are a bunch of nice like European and like Asian, like there's like languages like Persian, Hebrew, like they are not super high resource, but still they're like good, they're good data for them. So with the 100 language, that was really like, that included a lot of like African languages. That was a lot more challenging. So really, as we go, it's a bit unfortunate, but there is a correlation really between how well represented a language is and just like how easy it is to get a lift there. Like really, as we go further down the number of languages and their popularity on the internet and like the quality of data that we have, it was harder to also get improvements there. So yeah, I think that was one thing. And then another, so our team comes from different places in the world, and we also manually check the outputs of the models ourselves. So I did I looked at the Persian outcome, another friend looked at German, Turkish, and all of us were still coming up with examples like, oh, this looks okay, but it can be better, or like it's not really the way that a native person would say that. So on the surface, they look good. And that's not for every answer, but there are like some answers that you come by that looks like this. So I think even for these languages, there's still a lot of room for improvement.
Yeah, I have another question, Marzieh, and that is related to a problem we had in work. So at ING, we are using Gemini for the chatbot for the customer service. And sometimes there were like some slangs, like Dutch slangs, that it was very difficult for the LLM-based chatbot to comprehend and understand the meaning and give a proper answer. Are you guys also working on this kind of problems, or
Yeah,
too new?
I think, no, that's definitely, so when I talked about cultural exams, like this was really the case, like really examples.
Yeah.
So really like having samples about, because the majority of data for other languages, for these language models, come from translation at the end of the day. So that's a cheap way of generating data. And when you translate, like you can imagine the Dutch data for Gemini, like, and all of the other models, like if most of it comes from getting an English data set and translating into Dutch, there's no place for like Dutch slang. Like you don't really see that. So you have to purposefully find sources of these sort of examples and put that in your data, or
Okay.
create them in some way.
As an extra feature maybe on the data.
There's a lot of room there. I think that's actually what I meant when I say like the generations might look good, but they're not, like there's something missing, like a little bit, like this sort of knowing maybe like what a slang means, or like knowing maybe like a normal person wouldn't use that word in that place. Like this is really, and it's a very hard problem. Like this is just, yeah, like really a special like nuance of the generation. It's hard to measure, hard to evaluate, hard to solve. But I think it's a fun project to work on.
Yeah, and we have one last question. How does the multilingual model respond in recognizing dialects starting from official languages?
Yeah, that's a good question. So we are talking, so we might do a collaboration with building a model for essentially different dialects in like the UK, like Wales and Scotland, and like there are different and Ireland, like it's a big, so essentially short answer, like covering different dialects is kind of the next step. So once you speak a general, or like for instance, Arabic is a good example of that. So we have standard Arabic when we say a language model still can speak well in Arabic, but then I think there are like 10 or more different dialects, depending on the region that is spoken. So the next step of getting natural generations in these languages is really working on these sorts of nuances. So dialects is a big part of that. But you want to have the base, like you want to have the official language there first, because that's easier, because usually there's cross-lingual transfer that's happening between languages when you train a model that is multilingual. And the official language usually has the most amount of data, and then adding dialects on top of that would be the next natural step.
Great. Thank you, Marzieh. That was such a great talk. I hope everybody learned a lot about multilingual models. And if you have, I think, Marzieh, we will have the slides later.
Yeah, I'll share with you right away. And yeah, thanks a lot for having me. I appreciate that. Let me know if you also have any follow-up questions. You can reach out. And yeah, I'd be happy to help if anyone is also interested in working on multilingual language models.
Great. So feel free to reach out to Marzieh. I will put her LinkedIn on the chat so you can add her. And then if you had questions, you can follow up with her. Thank you, Marzieh.
Yeah,
See you
thank
later.
you. Have a good day.
Thank
Bye.
you. Bye-bye. Sarah, maybe you can close the YouTube stream, and then we can follow up
Yes,
first.
it's closed now.
Thank you so much.